Okay, guys, this is actually, it's kind of complicated. You need to understand a lot of stuff. First of all, let's assume we have a mass here sitting on the table, okay? And it's being pulled like this, okay? It's being pulled by the second mass, which is smaller than the first mass. If you remember, Dr. Dastan, he gave us a note that says if we have a pulley right here and it is attached to a second mass, the second mass, if it is smaller by a certain extent, it will move the bigger mass. And if we assumed, like, this is like really important, if the pulley has no mass, no friction, this case will be correct. By the way, by meaning no mass or no friction, it does not mean actually there is no mass or friction, because it is like, this is too theoretical to be even applied. We actually mean like the mass of the rope or the pulley, it has no friction and no mass. It means like the friction and the mass, it's really small to the point we can ignore it. And just like in calculus, when we have, for example, infinity plus 1, we can ignore the 1 because it's infinity. Here it's the same case. This is like too much, and this is too much, and this is too small, so we can ignore it. So first of all, we have to like understand the diagrams. He will ask for T. When we know like there is no mass, no friction, T1 will equal T2. Then, okay, if T1 equals 1 T2, we can find it easily by finding any of those. If he didn't give any kind of acceleration, because like we have a movement up here and we have a movement like this here on the x-axis, we can write the note for T2, and we have to remember these that we learned in the previous videos. If the acceleration is going downward, then the tension equals mg equals ma. And if it's going upward, the tension will equal mg plus ma. Okay, we write this. We can find, if you can see, like we can find the tension by just doing this, like m2 here. But we don't have acceleration. Okay, if we think about it, this is all only being pulled down. There is no up force. So we can use the whole system, the force for the whole system, to find the acceleration, because the acceleration here is the same acceleration here. So if we remember, like the F net, like it's equal ma. F net equals ma. And here the F net will be presented as the second one, because the second one is less complicated, since we don't have a normal force going up there. Okay, so it's gonna be it's gonna be m2g for the second, like for the second one, m2g equal the mass total for the whole system multiplied by the acceleration. Why we have one acceleration? Like I said, it's a whole system. The acceleration is going like this and the same speed from here. It does not mean it's constant, but it means because it's the same rope, so it is the same acceleration. So F net equals mass total multiplied by T. M2G, which is this one, as I said, because it's simpler, we will use it, equals M1 plus M2 multiplied by A. We can substitute A like this. We find A, then we apply it here, and we find the tension for the second case. And since it's the same rope, and there is no mass, no friction, no whatever, then T1 will equal T2.